Alright class, here we're going to get into rhombuses, squares, and trapezoids. So our warm-up for the day, we have a rectangle. We say that measure of angle WXY is 6a squared minus 6. We want to find a. So because we know this is a rectangle, and this is our angle we're trying to find, or we're looking at, that better be a right angle if this is a rectangle, sorry. So all we have to do is set what we know about it equal to 90. So 6a squared minus 6 equal to 90. We're going to add 6 to both sides. So 6a squared is equal to 96. And we divide by 6 on both sides. A squared is equal to 16. We square root both sides. Now, because we're not trying to find an actual number about this, and we do have this square inside of here, our a isn't just 4, it's plus or minus 4. When we square root the 16, we have to include the negative, because a could be negative 4 here. We're not looking at it possibly being a distance or an angle, so it can be negative, okay? Our second one, we have a rectangle again. We want to find the measure of angle VRS. That is the angle right next to the one we're given, the 38 degrees. So because those are right next to each other, they better well equal 90 degrees together when they are, this thing is a rectangle. So that means that we'll call this x plus 38 needs to equal 90. So we're going to subtract 38 from both sides. And x is equal to 52 degrees. Alright, so let's get into these notes. We've got quite a few example problems. They're not super easy. The first ones are pretty easy, but they do get more complicated as we go. Alright, lots of vocab for the day too. We got rhombus, square, trapezoid, bases, legs of a trapezoid, base angles, isosceles trapezoid, mid-segment of a trapezoid, and kite. Oh yeah, so really we have kites too. I forgot about those guys. So we have rhombus, square, trapezoids, and kites that we're looking at today. Alright, so first things first, diagonals of a rhombus. Cool thing about diagonals of a rhombus, they are perpendicular. Their intersection in the middle is perpendicular. So they make 90-degree angles, and also they bisect the angles they come from. So if they go from R to P, so like you can see here, they bisect those angles and make 1, 2, 3, and 4 all equal to each other. It's pretty cool. Okay, so if you need to pause it, write it down. Go ahead. We're moving on. We're going to use these. So the diagonals of rhombus WXYZ intersect at V. If WZX is equal to 39.5, we need to find the measure of angle ZYX. So, come on, here we go. Making my app didn't want to write anymore. So WXZ or WZX, sorry, is our angle right here. That is our 39.5 degree angle. And you want to find the measure of angle ZYX. ZYX is right here. That's the angle we're trying to find. So, we know that the 39.5 degree angle is also here, right? It's also up here. And it's also right here, right? Because they bisect these angles. We also know that inside here, these better be right angles. In order for these to be the diagonals, they have to be right angles, and this to be a rhombus. So, notice we have 4 triangles here, right? And missing the angles in that corner together that divide in half because it bisects, right? So that means that, well, for one, we have all these triangles, right? We know that the sum of all the angles of a triangle you need to add to be 180. So the 90 plus the 39.5 plus our mystery angle that I'll label in blue down here, right here. We'll call it angle X. That's what we're trying to find. So we find that, we double it, we got our answers, okay? So 39.5 plus the 90 is equal to 129.5. We subtract the 129.5 from both sides, and X is equal to 50.5. Now, that angle down there that we're looking for is 2x, basically. So 2x is equal to 101. And that's our answer. Okay, next one. Same image. Now we know that same thing, diagonals going on through there. If WX is 8x minus 5 and WZ is 6x plus 3, we need to find x. So because this is a rhombus, all the sides are equal. That's what makes a rhombus different than a square, or not different than a square, different than just a regular old parallelogram. A square has, well, you'll see in a minute. Anyway, well, obviously 4 right angles, right? So basically, all we have to do is set these two things equal to each other. So 8x minus 5 equal to 6x plus 3. Subtract 6x from both sides. We got 2x minus 5 equal to 3. We add 5 to both sides. 2x is equal to 8. And we divide by 2. X is equal to 4. And that's all we need to do. We didn't need to find anything else out or use x to find what the lengths of the sides are. Okay? Alright, so all this says is just kind of a Venn diagram, or just a diagram in general of all things that are the same. So parallelograms are on the outside of this whole huge circle, and then inside of parallelograms are rectangles and rhombi. So rectangles are parallelograms with 4 equal angles, or 4 right angles, and rhombi are parallelograms with 4 congruent sides. And then inside of, or when those two overlap, that's when you get squares. You got 4 right angles and 4 congruent sides. That's what makes a square a square. It is a parallelogram with all 4 of those things, all of those things happening. So, okay. So conditions for rhombis and squares, we already kind of know the first two. These are just the converses of the two we already looked at. So if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So just the converse of what we said before. If one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. Same idea, just converse. Next two are kind of new. First one, if a pair of consecutive angles of a parallelogram are congruent, the parallelogram is a rhombus. So if you see here, we have two sides that are right next to each other. They are congruent. And this thing is a parallelogram. It's kind of key. Then the other two sides are congruent. This thing is a rhombus. And then the last bit, if a quadrilateral is both a rectangle and a rhombus, then it is a square. So using what we did before with rectangles, so either all the angles are right angles or the diagonals are congruent, and then it's a rectangle. And if any of these things are true, then it's a rhombus. If it's both of those two things, it is a square. So, for example, here we have, is there enough information to prove that this is a rhombus? We know it's a parallelogram, and we know that these two sides are congruent. And based on what we just saw, yes, we can prove that this is a rhombus. So yes, according to theorem 6.19. Not even going to give any more information on the last slide. If you need to go back, rewind, look at the slides on Classroom, whatever you need to do. Okay? Next one here, Hector's measuring the boundary of a garden. He wants it to be square, which means it needs to be a square. So the only thing he knows right now is that his stakes are 6 feet apart. So that tells us that he at least has a rhombus, right? We know that those two sides next to each other, being the exact same thing, make this a rhombus. Now, the last bit we don't know is if it's a square. And all we need to know, if we know it's at least a rhombus, we need to know if it's also a rectangle. If it's both of those, it's a square. So that's what we need to tell, is if the diagonals are also the same. If you guys have ever done construction, you know that you need the diagonals to be the same. Recently I built a porch, and when we were rebuilding our porch, we made sure that the diagonals were the same, make sure that this thing was rectangular. So square in construction means that it makes right angles, not that it makes a square necessarily. So that means that that's what he needs. He needs to, so Hector needs to make the diagonals equal. And if he does that, keeps those sides 6, he's good. He's got it square. Because you can make a rhombus easy with 4 6-foot sides, but if you want it to be a square, you need to make sure the diagonals are equal as well. Okay, our next one here. We need to know if this parallelogram is a rhombus, rectangle, or square for these things, and we need to make sure to list all that apply. So we have these points given to us for it. There is an image we can see here, so just if you don't know what it looks like on the coordinate plane, it looks pretty square, right? So let's just make sure that it is. So what we're going to do first is find if it's a rhombus, and then if it's a rectangle. So really you can go either direction with this. We're just going to use the distance formula 4 times, okay? So first thing we're going to do is find if 2 consecutive sides are congruent. So we have AB so if this is congruent to BC, or for that matter, if it's congruent to AD, you could do that one as well. It should be a rhombus. So we have -1 minus a -3 squared. Oh, not -3. 2. Sorry, I looked at the wrong thing. Plus 3 minus a -1 squared. That comes out, let's see, -1 plus 2 is 1, and 1 squared is 1. And 3 plus 1 is 4. 4 squared is 16. This is the square root of 17. So we should get the same thing for BC, again, AD if you want to. And if you don't, it's not a rhombus, which means it's not a square. So the only thing would be left is it could be a rectangle, but doubtful at this point. So we got -1 minus 3 squared plus 3 minus 2 squared. -1 minus 3 is 4, and 4 squared is 16. So far so good. If this is 1, and it is, 3 minus 2 is 1, 1 squared is 1, and that is equal to 17. So that checks. We know it's at least a rhombus. Now, the last thing to do is, not the last thing, but last parts are to check to see if it's a rectangle. So we're going to do the same process. We're going to do AC now, our diagonals. So AC, distance, formula again. And that's going to be a -2 minus 3 squared plus -1 minus 2 squared. So this is equal to -2 minus 3 is -5, and -5 squared is 25. -1 minus 2 is -3, and -3 squared is 9. And 25 plus 9 is equal to the square root of 34. Okay, so now, last thing we need to do is for BD, the other diagonal. If we get the exact same thing we just got, this is a rectangle, and because it was a rhombus, and now it's a rectangle, it's also a square. So, -1 minus 2 squared plus 3 minus a -2 squared. -1 minus 2 is -3, and -3 squared is 9. 3 plus 2 is 5, and 5 squared is 25. Got the same numbers in reverse order, so that means it's still a square root of 34. So that checks as well. So this is a rectangle as well. And when we have rhombus plus rectangle, that's equal to a square. Alright, moving on. We've got a lot to do still. So isosceles trapezoids. So we're getting into trapezoids and kites now. So first ones we got to deal with are these laws, or these theorems. So if a trapezoid is isosceles, then each pair of base angles is congruent. If a trapezoid has one pair of congruent base angles, then it is an isosceles trapezoid. Kind of the converse, but not really. A trapezoid is isosceles if and only if, so that means this could go both ways, if its diagonals are congruent. So, just like a square or a rectangle, the diagonals are congruent for trapezoids, but the top and bottom are not the same length. So, here's a basket that's the shape of a trapezoid, isosceles trapezoid to be exact. If the measure of angle JML is 130 degrees, that's this angle down here, and KN is 6.7, MN is 3.6, this is 130. We want to find the measure of angle MJK. MJK is up here. So, this one's all focusing on the angles. So because we know we have an isosceles trapezoid, If you remember back to the rules we just looked at, we should have two that measure the 130, and we should have two that measure some other number. So we're going to add these two 130s together, that's 260. So now, again, if we go back to the unit, or the first notes from this chapter, we know that when it's got four sides, 4 minus 2 times 180 will tell us how many degrees all the angles need to add to be. So 4 minus 2 is 2. 2 times 180 is 360. So 360 minus the 260 that those two angles get us is 100 degrees. And we divide that by the other two into the other two angles, and that means that the angle is 50 degrees. And that's it. So the next one's even easier, if you can imagine it. But we're going to use the same numbers. The 3.6, the 6.7, and the 130 will stick around. So here's our next one. Like I said, those numbers stay. So this one is 6.7, 3.6. And now we're trying to find JL, so I'm not going to write the angle down, but we know that this is the one. I guess I'll write it. 130. So, again, isosceles trapezoids means that the diagonals have to be congruent. So, when we add these two pieces of this diagonal together, that should be equal to what JL is as well. So, 6.7 plus 3.6. Oh my god, they did change. 10.3. My bad. I did not notice that. It's 10.3. So, add those together, and you should get 17 feet. It's a huge basket. Okay. Next one here, we have a trapezoid on the coordinate plane. This is our longest problem here. So what we have to do here is actually find the slope of each of these to find out if this is a trapezoid first. And if it is a trapezoid, is it possibly an isosceles trapezoid? So doing that means we could find the diagonals and see if they are equal, or we could also find the sides, so the two legs of the trapezoid. Either of those things need to be equal to make this an isosceles trapezoid. So first we need to check if it's a trapezoid at all. So that means that we need at least one pair, or we need exactly one pair of opposite sides parallel to make it a trapezoid. So for AB, we're going to find our slope. So that's going to be -1 minus 1 over -3 minus 5. That's -2 over -8. That is equal to 1 over 4. Okay? Let's look at the same thing for CD, because CD needs to be parallel to this in order for this to work. And really, that's it. If the other two are parallel, then something's not right. So CD, at least visually anyway, something's not right. So 4 minus 3 and 2 minus a -2. So 4 minus 3 is 1, and 2 plus 2 is 4. We got our 1/4, so that checks. This makes it a trapezoid, at the very least. But we got to make sure the other two are not parallel as well. So let's do that. So AD gets us 1 minus 4 over 5 minus 2. 1 minus 4 is -3. 5 minus 2 is 3. That's a -1. And for BC, it's 3 minus a -1 over -2 plus 3. So 3 plus 1 is 4. -2 plus 3 is 1. So that's 4. So that checks it out. Alright. So we definitely just have a trapezoid. We don't have a parallelogram or anything. So now, if we check to make sure our distances of the legs are the same, that'll make it an isosceles trapezoid. So, AD for distance now. So, square root of 2 minus 5 squared plus 4 minus 1 squared. So that's going to be the square root of, so 2 minus 5 is negative 3. Negative 3 squared is 9. And 4 minus 1 is 3. 3 squared is 9. So that is the square root of 18. We'll leave it like that. And BC is going to be negative 2 plus 3 squared plus 3 plus 1 squared. So that comes out to be negative 2 plus 3 is 1. 1 squared is 1. And 3 plus 1 is 4. 4 squared is 16. 16 plus 1 is 17. Uh-oh. That means it is not isosceles. Those need to be equal to be isosceles. Alright, so the rest of our problems today are not too long. So our next theorem here states that the mid-segment of a trapezoid is parallel to each base, and its measure is 1/2 the sum of the lengths of the bases. So it's kind of like the average of the other two sides, as long as it is the mid-segment. If it's not the mid-segment, then that's not that. Okay? So we're given that MN is our mid-segment here. It's 30. KF is 20. We want to find JG, which is X down the bottom. So we know that X plus 20 divided by 2 should be equal to our mid-segment. So we multiply by 2. X plus 20 needs to be equal to 60. We subtract 20 from both sides, and X is 40. And that's it. Like I said, the next problems are pretty simple. So now we're getting into kites. So kites are actually pretty cool things to work with, aside from flying them in the air. If a quadrilateral is a kite, then its diagonals are perpendicular, similar to rhombuses, or rhombi. If a quadrilateral is a kite, then exactly one pair of opposite angles is congruent. So here, basically, it's got angle side angle on both sides of this thing. It's like two angle side angle similar triangles can form together to form one shape. Okay? So here's our first one. We know it's a kite. That means that the 121 degree angle is also on the other side. So 121 plus 121 plus 73 plus the other angle, we'll call it y, because that's what it is, needs to be equal to something, right? So remember again, 4 minus 2, so same thing, 180, and that's going to be 2 times 180, that's 360. So basically, squares, rhombuses, kites, squares, rhombi, kites, rectangles, parallelograms, and trapezoids all have 4 angles and 4 sides, so that means they all need to have angles that sum between 360. Pretty cool that all those shapes have the same things going on. So 121 plus 121 plus 73 is 315. And we're going to subtract that from the 360. So y comes out to be 45 degrees. Okay, next problem is our last one. So, again, we have a kite. We want to find NP. That's where I'm marking it red X. But that's also here, right? It's the same thing. And if you note, remember, that means that just make a right angle, because those are the diagonals, and we have a right triangle here, so we can use Pythagorean theorem. So our legs are the 6 and the 8. We're looking for the hypotenuse. So 6 squared is 36, 8 squared is 64, equal to x squared, that's 100, equal to x squared, and that means that x is equal to 10. Pretty easy. Here's your exit ticket. Get it done, and we will see you next time.